Hello family, my name is Mr. Simultaneous and I'm also known as Coach Boo. Welcome into the Mathsbuddies channel. In this channel, I get to share with you methods to solve any maths topic that you might or might not be struggling with as a grade 11 or a grade 12 learner. So if you are new to the channel, I would like to welcome you and I would like to please subscribe so that you won't miss when another video gets uploaded. So without further ado, I'm going to jump straight into this week's session. This week we'll be talking about patterns, sequence and series. I have two questions where I shared with you, and in these two questions I want to share with you methods to basically understand what to do when you're encountering this type of question. So the first question, it is a combined sequence. Now the question goes as follows. Given the combined sequence 4, 8, 6, 18, 8, 32, 10, 50 and so on. Now whenever you encountering a combined sequence, it is important that you always do this. Now a combined sequence, you know that it has two sequences, right? Now the first sequence, it has its term located in the odd numbered position of terms, if I can put it that way. So what do I mean by this? I'm saying the first term, the first sequence, you will notice that its terms are term 1, term 3, term 5, term 7, term 9, and all the odd numbers, and so on. And then another sequence, it will be the one in the even, which is term 2, term 4, term 6, term 8, term 10 and so on. So this then means now whenever you're encountering combined sequence, the first two things that you should do before you even go to the question is isolate the sequences, right? So when we're isolating these sequences, you'll notice that the first sequence, it is 4, 6, 8, 10 and so on, right? And then the second sequence, it is 8, 18, 32, 50. All right. Now, is it important to know, or is it important for you to expect for them to give you the type of sequences in the question? No, it is not, but it is important for you to isolate them. Now once you isolate them, please understand that when you have isolated them, this is term 1, term 1, term 2, term 2 of the different sequences. But if you combine them, this 4, it is term 1 there, but this 8, it is term 2 there, right? So in the question, they will ask you, for example, to calculate term 100, right? So what you need to know is to basically understand the value 100, is it an even number or is it an odd number? So if it is an even number, then it means because of we got these terms from the even position of the terms on the combined sequence, then this means the numbers that have to do with even number, it will belong here. But now watch this now. If it says it's term 100 in the question, that doesn't mean it's going to be term 100 here, because the term 100, it means there is 100 terms in the combined sequence. So this means if it's term 100 and then you want to isolate term 100, it is going to be half of that to actually calculate here. So what do I mean by this? I'm saying if it is term 100 in the combined sequence, let me just write here T100, then you should know that here in the isolation it is equivalent to term 50, right? Now this number, it is an even number, but this one, it doesn't matter, it doesn't have to be even number. This one has to be even, but this one, it's okay, it can be odd. What about this part? Second part, same thing. These numbers, we got them from the odd numbered terms in the combined sequence. So this means now here we have odd, right? So whenever we're being asked a question that is an odd number, we should know that we're being asked about the term number that belongs in this sequence here, right? So this then means if they want us to find, for example, T25, right? Then now T25, because if it is an odd number, and then we basically cannot divide this number by 2 to get a solid number, right, or a natural number, then it means if in the combined sequence they said term 25, what you're going to do in that 25, you're going to add this 25 by 1, which will be, it's 26, right, which is then term 13. There you go. So that means now the term that you're looking for in the isolation, it is term 13, because we have isolated the sequence now. Now this is basically the first thing that, this is the first method that can basically help you answer all the other questions that will come after, right? So let's go ahead and look into the first question, which is 1.1, and see what it has for us. Now the first question says, write down the names of the two sequences that are found in the combined sequence. Alright, so now here, as you can see, we've already isolated them, but we just need to identify what is the first sequence and what is the second sequence. Now let's go ahead and look at the first one. Now the first one, we have 4, 6, 8, 10, and so on, right? Now the test, we always start with the arithmetic sequence. So let's start by testing whether it's the arithmetic sequence. 6 minus 4, 8 minus 6 is 2. As you can see here, we're getting a common difference. Therefore, this is arithmetic. Now let's go ahead and look at the second one. Second one, it is 8, 18, 32, 50, and so on. Now let's test this one. Is it arithmetic? Let's see. 10. Now 32 minus 18, that's 14. 50 minus 32, that is 18. Now is this the first difference common? No. Now let's see if we're going to have a second difference that's common first. Second difference, so we're testing for quadratic now. 4, 4. There we go. So now here we have a second difference. Now this then means this is quad, right? Therefore our answer, you're going to say arithmetic and quad. Let's go ahead and look into the second question. So I hope this makes sense. Now you see how basically this helped us to understand what this combination was for, like this first step when we're isolating these things, right? So it's very important that we always isolate. Now 1.2 says write down the next two terms. Now the next two terms, we know that here at 10, to get the next term, we're going to add 2, right, to get the value there. So this is basically 12, right? Then here on the quadratic, we know we first need, let me just remove this, we first need to add a second difference to get the value there. So 18 plus 4, it is 22. And then now that's when we start adding. Then 50 plus 22, it is 72. Now here, these values, where do they belong, or how do we put them in the combined sequence? Remember, this was the arithmetic, so that means the arithmetic needs to skip one term to sit there, so it's going to be 12. And then the quadratic, it skips that 12 and sit there, which is going to be 72. So this then means the terms, the next two terms, it is 12 then 72. Now don't make the mistake of saying 72 then 12, then it means this is going to be wrong, right? It needs to basically follow the order. Alright, 1.3, okay, let me just open a new space. Now 1.3 says let's calculate the value of the 80th term in the sequence. Now here you see, here we are being asked to calculate the 80th term in the sequence, but now here, because of its combination of two sequences, we can't just calculate the 80th term from there. We need to first isolate that, or we need to take that and see what it means into our isolation of sequences. Now 80, what is 80? Is 80 an odd number or even number? So it means it's an even number, right? So now if I want to calculate term 80 and I've isolated that means this 80, when I divide it by 2, I get 40. So it means in the isolation, what I'm trying to calculate here, that is term 40. So now I will take the equation in the isolation and then I'll calculate T40 from it, right? Now 1.3, let's see that sequence again. There's 8, 18, 8, 18, 8, 18, 32, 50, right? We said the first difference, it was 10, and then this was 14, and this was 18, and then this was 4, right? Now in this sequence, we want to calculate term 40 here. Now in order to do that, first we need to find what is Tn. Now this is quadratic, so we know that Tn is an squared plus bn plus c. Now to achieve that, what we're going to do is first we need to know what is a, what is b, what is c. Now to do that, we know we have the 3 steps that we follow, right? Now the first step, we always take the second difference and then we equate it to 2a, so second difference is 4. And then the second step, we're taking the first term of the first difference, 3a plus b, and then we equate it, 10, and then we equate it with 3a plus b, and then the first term we equate it with a plus b plus c, right, which is equals to 8. Now when you solve for a here, so we're going to start with the first one, solving for a, we get a as 2, then we take the a, substitute it there, we get 6 plus b is equals to 10, which then gives us b as 4. Then we take a, put in there, take b, put in there, and then that is 2 plus 4, which is also 6. And then from there we're going to say plus c is equals to 8, and then the value for c is then going to be 2. This then means now our Tn, it is 2n squared plus 4n plus 2. Now what do we do here? We then calculate T40 of this. Now T40 is going to be 40 squared plus 440 plus 2, and when we press this calculator, our answer is 3,362, and that is basically the value for T40. Now this then means that T80 is 3,362, because you need to take it back into what the question asked. The question asked for T80. Now let's go ahead and look at 1.4 and see what it wants us to do. Now 1.4 says determine the position of the term 202 in the sequence. Now here we know a term number, which is 202, and then we want to know in which term does it belong into this combined sequence. Now in order to do that, we will need to test the value, right, to see which term or which sequence between these two we're gonna actually get the position term, or are we going to get the value for n. So this means what we're going to do is we're gonna go into 1.4, and then we're gonna find both sequences, and then in both sequences we're gonna calculate the value for n. And then if we're getting a value that is a natural number, then it means that sequence is the one that basically has the value 202, or that's where you can find the value 202. So here already we have our Tn for quadratic. Quad Tn is 2n squared plus 4n plus 2. But now we need to know what is the arithmetic Tn. So in the meantime, we still have a plus n minus 1 d. Now from the isolation that we had, we can see that the value for a was 4 and d was 2, right? So here, what we do know, a is 4 and d is 2. So when we substitute those, we're gonna get 4 plus n minus 1 into 2, which is then 4 plus 2n minus 2, and then it's 2n plus 2. So that's the arithmetic sequence. Then from these we'll use 202 in both sides to see if we're going to get n. So I want to start with the arithmetic. Since we've already applied the quadratic, I want to start with the arithmetic. So starting with the arithmetic, 2n plus 2, right? Then now we know that the value for Tn, it is 202, and I calculate n. So let's go ahead and do that. Now 202 is going to be 2n plus 2, and then move it over. We're going to get 200 is equals to 2n divided by 2 divided by 2, and then we're going to get n as 100. Now this is easy, as you can see we got n already, then that's 100. So this means now this n is equals to 100. Remember, it is on the isolated one, right? It's on the isolated one. So if you want to find out in which term is it located there. What you're going to do is just like we did earlier on here when we took the number, right, when we took the number and added by 1, and then divide this value, because this was in the combination, into this. What you're going to do first is, if you want to reverse that, to get the actual number of n, to get the actual number of the n in the combination, we'll take the value that we got for n, and then we multiply it by 2. So by multiplying it by 2, it means that we are also considering that there is another sequence, because it's a combination of a sequence. We know that in order for us to get another term in the combination of the, we know that in order for us to get another term of the arithmetic sequence in the combination sequence, we first have one term and then we skip one term to get into another term. Hence we're multiplying by 2, right? So here we move 2 terms to get to the second term of the arithmetic, basically. Hence now we're multiplying it by 2. So this then means now here we multiply this by 2, we get 200, right? But now remember, 200, it is a number that belongs only in the even numbers, right? In the quadratic sequences, and then in an arithmetic it needs to be odd. So because if we want it to be odd, we then subtract it by 1. So remember, at first we had an odd number, and then we added it by 1, then divided by 2. Then now if you want to do it in reverse, you first multiply it by 2, then you subtract it by the 1. Then this then means it's going to be 199. Therefore T199 on the combined gives you 202, and that is your answer. So I hope the explanation made sense. Now let's go ahead and look into 1.5. 1.5 says prove that the sequence will always have even terms. We need to prove that the sequence will always have even terms. So what does that mean? So to have even terms, we know that a number, it becomes an even number once you multiply it by what? By 2. So now it means now what we need to do is we need to take this Tn, and then we're going to write it in a form in which we can have a sequence multiplied by 2, right? So now let's go ahead and look into the first one so that I can explain this by writing, right? So let's go ahead and look into this one. For example, this is 2n plus 2. Now looking at this like that, we cannot tell whether this is going to be an even number, right? But now if I take out the common factor of 2 and then have a remainder of n plus 1, I know that whatever that I get in n plus 1, if I multiply it by 2, that answer is going to be even. So this then means now Tn, all the values here that I will get here are going to be even, right? And let's go ahead and look into the second one. Same thing, 2n squared plus 4n plus 2. Here I cannot tell whether this is going to be even, but if I take out the common factor, right, then now I know whatever that I get here, if I multiply it by 2, is going to be even. So this then means now if both of them give me even number, so this means both are always even, or both will always be even, and that is basically our answer. And that is all for the first question. Let's go ahead and look into the second one. Now this second question, this is the one that you usually get, where you'll be given a statement and then you will have to basically generate equations in order for you to basically find what the question is asking about. So this is called, I think it's called patterns with simultaneous equation, or simultaneous equations in patterns, something like that. But here I want to show you how this basically works. But first let's look at the question and read it, and then from there I'm going to give you a hint to how to basically take the information and write it so that you can understand what's happening. Now the question goes as follows. An arithmetic sequence and a geometric sequence have the first two terms the same. If the first term is 4 and the sum of the first 3 terms of the arithmetic sequence is equal to the third term of the geometric sequence, determine the first 3 terms of both sequences. Now the strategy to solve this question, it is basically to to read each statement and understand what it means. So let's go ahead and read the first statement. So the first statement, it says here that an arithmetic and a geometric sequence, right, have first 2 terms the same. So this means now here, first thing that you need to do is you need to say that you have an arithmetic, write it down, and then to second part, the geometric. Now, because of they said we have an arithmetic sequence, it is important that you write that formula of the arithmetic. I'm going to tell you why. Now, do the same thing, right? I'll basically tell you right now why that is important, right? Then now here, what did they say? They said they have the first terms the same, right? The first two terms, actually, they have the first two terms the same. So what does this mean? So this means if I'm looking at the arithmetic, right? My arithmetic, I know that my first term it is a, then my second term it is a plus d, right? And then my geometric, I know that my first term is a, and then my second term it is ar. So these terms are the terms that I have in general, right, on an arithmetic, and this one is in the term that I have in general in a geometric. Now they're saying that these terms are the same. So if they are the same, that means if I add this term and that term, the answer I'm going to get is going to be the same. So this then means now here a plus d is going to be the same as a plus ar. Now do you see, this is basically everything that you've got, only the first sentence. You haven't gone to the second one, right? So this hence I'm saying it is very important for you to read the sentence and then try to understand what it means. But now here I'm trying to help you to basically uncover all the things that are hidden in a statement, right? Alright, now here we see that a plus d is the same as a plus ar. So if I cancel this and that, then I'm left on this side with a plus d, and then in the second part is ar, right? So this basically is the first sentence, everything that you got from the first sentence. Let's go ahead and look at the second one. Now the second sentence, it says if the first term is 4, watch this, if the first term is 4 and the sum of the first three terms of the arithmetic sequence is equal to the third term of the geometric sequence, then comma, so which means this is a sentence, done sentence. Now determine the first three terms of both sequences. Alright, now here we see here that the first sentence they're saying that if the first term is 4, right? Now we know that in English the minute you see and, then it means there's going to be another sentence. So now here the first sentence they're saying that the first term is 4, right? So they're saying T1 is 4. T1 is 4, right? So if T1 is 4, we know that this means T1 is A, so this means A is 4. So now with that in mind, then it means we need to basically update what we have there. So if we have A as 4, then this means this first sequence or this equation that we got in the first sentence, it is 4 plus D is equal to 4R. Now as you can see here, I can work D as 4R minus 4, and that's basically my first equation. So I can either leave it like that or work with that. So we'll be basically looking to both of these so that we can see whether they can help us, right? Then the next question, the next sentence, it says, and the sum of the first three terms of the arithmetic sequence is equal to the third term of a geometric sequence. Now, third sentence, it says the sum of the first three terms, right, S3 of the arithmetic sequence is equal to the third term of the geometric sequence, right? So what does this mean? So this means in the arithmetic sequence, if I have three terms, let me just add a third one there, three terms like that, the sum, when I'm adding all those terms, right, these terms, when I add them, they are the same as, let me just use a different color for this. Oh no, this is okay. They are the same as this one. So this whole part, or this whole set of terms, when you add them, it is basically the same as this term, right? So this then means now here on the left part, I know that I have A plus D plus A plus 2D, because that's the sum of the first three terms, right? And then this is the same as, or this is equal to AR squared, right? Now A plus A plus A is 3A, D plus 2D, it is 3D, it is equal to AR squared. Now remember, what was A? a is 4. So if I'm substituting a there, I'm getting this, which then is simplified into 12 plus 3d is equals to 4r squared. Now do you see here I get another equation, right? Now what's the question says now? Now with these two equations, let me just write here. First equation is d is equals to 4r minus 4. That's equation 1. Then the second one, it is 12 plus 3d, which is equals to 4r squared. That's my equation 2. Now this question, now it says with these two equations that I have, I need to find the first three terms of both sequences. So which means in this part I need to basically know what is the arithmetic and I need to know what is the geometric sequence. Now how do we do this? So now to do this, we're going to apply the simultaneous equation, right? Now I can see d is equals to 4r minus 4. Now on that other side I also have symbol for d, right? So this means now what I need to do first, I need to substitute the value for d, which is 1, into equation 2. Now what is equation 2? Equation 2 is 12 plus 3. Now there is d, so when we substitute there, when I have 4r minus 4, right, equals to 4r squared. And then now let's work this out. 12 plus, not equal, plus 12r minus 12 is equals to 4r squared. This 12 cancels with that, and then here I have 12r is equals to 4r squared, right? And then now let me take this over, so it means 4r squared minus 12r equals to 0. Divide by 4, divide by 4, divide by 4. Then r squared is equals to, sorry, r squared minus 3r is equals to 0, right? And then now here I have r into r minus 3, which is equals to 0. Now r is equals to 0, or r is equals to 3. Now here I got r, and then we know that r is a constant ratio. Now here constant ratio, we cannot have it equals to 0, so it means r cannot be 0, and therefore r, it is 3. Now with that in mind, that means now I need to use that to basically calculate d. Now if you remember, d, therefore d was 4r minus 4, right? So this then means d is equals to be 4, 3 minus 4, and then this is 12 minus 4. Now 12 minus 4 is 8, right? So I have my constant ratio as 3, and then I have my constant difference as 8. And so now this then means I know that here my a is 4, then also there I know that a is 4. So now to run the, or to generate the first three terms of a geometric, my first term is going to be 4, and then to get to the next term I need to multiply by 3. So 4 times 3 is going to be 12. 12 times 3 is going to be 36. Now what about my arithmetic? Now in my arithmetic, I know that my first term is 4. Now to get to the next term I need to add 8. So 4 plus 8, that is going to be 12, plus 8, that is going to be what? Going to be 20. And those are my 3 terms, or the first 3 terms of both sequences. Now notice this. Do you remember the statement when it said they have the first 2 terms the same? Look at the first 2 terms. Look at this. The same, right? But then after that, of course, the terms were not the same. So if you like the video, make sure that you share with your friends so that they can also be able to get this valuable information, so that they can be better prepared when they are about to write their first term exam. And also make sure that you leave a comment and tell me what you think about the video, or what type of questions that you would like us to do, because my aim on this channel is to share with you methods to basically solve any question that will be given in the topic, so that you can be basically prepared when you're about to write your term 1, term 2, term 3, and also your final exams. And I'll see you basically on to the next one. Cheers.